Hello friends, welcome to SYE Academy. In this video, we are going to discuss about Liskov substitution principle. In the solid design principles, this is the L, right? We have already discussed S and O. And Liskov substitution principle looks to be the toughest to people. Let me try to make it simpler. First of all, about the definition, if somebody asks you or if you are preparing for your exams in college, then objects of a parent class, right? Parent class should be replaceable with objects of child class. That's what it is saying. And they should be replaceable and your program should not break. If it is being followed, then Liskov substitution principle is working fine. If not, then there is some issue. Now, what does it mean in simple language? In simple language, it means that let's say there is a parent class and let's say there is a child class B, then B should behave exactly like A, right? That's what it is trying to say. I mean, think very simply. I mean, don't overthink. If you are writing inheritance, then ideally all derived classes should behave like parent classes, right? For example, I'm just taking one example. Let's say vehicle is there, right? Then car, if it's a child class, right? If you are making car as a child class, then car should behave like a vehicle. It should not behave like a human, right? That's what it is trying to say in simple terms. Now, why LSP or Liskov substitution principle matters? It prevents runtime errors, especially if you are not following inheritance correctly. Let's say if you are trying to do like, okay, let's say your vehicle flies, right? Now, if you are trying to call C, if you have car as your class and C is the object, right? And let's say you are trying to write it like this and you are calling c dot fly, right? Then it will fail because car cannot fly. Or maybe let's say usually we write it like this. Let's say if it's a parent class which is vehicle, and if you are doing c dot fly, right, even this will fail, right? Even this will fail because your car cannot fly. So that's why in this case you are not following LSP, Liskov substitution principle, because you are breaking your code. It makes inheritance safe, right? For instance, if you are saying that, okay, uh, there are two type of vehicles. One is the flying vehicles, right? This is one class. Second class is non-flying vehicles, right? This is second class. And car is extending this non-flying vehicles, then c dot fly will not be there, so you are not breaking inheritance, right? You are also following Liskov substitution principle. It allows polymorphism to work correctly, as I just explained, helps you design reliable classes hierarchies. If a subclass changes expected behavior, your entire systems become unstable. Just imagine you are trying to invoke c dot fly, then it will fail basically. See some more examples here. Let's say there is a parent class car and it can drive forward. Very good. Now there is another child class which is electric car, and electric car also drives forward. Let's say it has a method which is forward, right? And you are writing something like c dot new electric car, right? Electric car is a drive class. So c dot forward will work fine, no issues here. But if you are writing something like another child class which is a toy car, and toy car does not move forward, so if you try to do t dot forward, it will fail because this car does not move forward, right? Or as you can see in this example, this c dot drive will fail. So your program breaks because toy car cannot actually drive. This violates Liskov substitution principle, and also hope you can understand the problem. It cannot access that function. But yes, okay, you can write something like, okay, you are inheriting uh, car and you are overwriting a drive function and you are throwing exception here. Yes, you could do that, but this is not the correct way of writing program, because at the end of the day you are throwing an exception. This is exception basically. This is not the right way. So you are not following the right principle. A bad code. Let's take another example of LSP. If there is a class bird which and you have a function fly, right? You will write it like this because all birds fly, but you have not thought about it, all the scenarios. Let's say somebody is writing class ostrich later, let's say after 2 years, and that guy is extending it with bird because ostrich is a bird, right? Similarly, chicken or rooster is a bird, right? But they don't fly. And you are throwing unsupported operation exception because ostrich cannot fly. So this again breaks your Liskov substitution principle. An ostrich is not a bird in the behavioral sense of flying. Replacing bird and ostrich breaks the program. Now your question could be how to solve this. Maybe you can write in the comment section. Pause this video and write in the comments. Now let me explain it to you in a very simple way. You will write interface, write bird, and one interface will be flyable bird, which will extend bird or uh, which will implements bird. Maybe you can write it as class. Okay, I think that will be better since it is writing extends. Now class sparrow is implementing flyable bird and class ostrich is implementing bird. I mean, you can keep it as interface or you can keep it as class. Better to keep it as interface. First of all, let me tell you, better to keep it as interface because abstract classes are rarely used anymore. Anyways, we are not discussing interface versus class here, but let's say if it's interface bird and there is, so what you will do, you will create another interface flyable bird, right, which extends bird. And so class sparrow will come from bird, will come from flyable word, apologies, will come from flyable words, but ostrich will implement bird only. It will not be, it will not be implementing flyable bird. So basically you have separated it into two categories, flyable birds and non-flyable birds or normal birds. So now code never expects ostrich to fly and subtypes match expected behavior and Liskov substitution principle is. Now, the core idea to remember is a class should not override behavior in a way that breaks expectation of the parent class. That's what you need to understand. If a class throws unsupported exception, requires stricter rules, or you are doing some hacks, right? Changes return meaning, workflows, then you are violating Liskov substitution principle. Now, in interview, you can give some answer like this, that Liskov substitution principle ensures that subclasses behave consistently with their base classes. If a derived class changes expected behavior or breaks invariants, inheritance becomes unsafe. That's why I design hierarchies where each class strengthens, not weakens the parent class behavior. Maybe you can give answer like this to set a good reputation. Now I am asking three questions and I expect you to write it in the comment section. A square class extends rectangle class but changes with height behavior. Is LSP followed or not? Write it in the comment section with 1, 2, 3. Right? Let's take the second question. A no op logger extends logger but silently logs nothing. Is LSP followed or not? Third question is a file payment processor extends payment processor but throws exception for online payments. Are we following LSP here or not? So this was about Liskov substitution principle. Basically, your child class should be able to overwrite and should be able to implement all the functions of the parent class. If it is not doing it, then it is breaking Liskov substitution. This is the Liskov substitution principle. Hope you liked it. Thank you and take care.